In today's video, we're looking at how sports scientists can use basic statistics in R. So we can look at some basic summary statistics. So we can use the range, which is going to show us the distance between the smallest and largest values. We can look at the interquartile range, which shows us the difference between the third and first quartile. We can look at the mean, which is going to be the average of our data points, or we can look at the median, which is going to be the middle most value in that list. We can also look at the standard deviation, which describes the spread of our data, or we can look at the variance, which also describes the spread of the data, but it does so in relation to the mean. Now, standard deviation and variance can be kind of confusing because they are so similar, so I've included some images that kind of show the differences between standard deviation and variance. We can also take a look at some descriptive statistics using R. We can take a look at the z-score, which is going to be a standardized measure of a value's relationship compared to a mean. So it's going to show where that data point lies in relation to the rest of the data. We can also take a look at a correlation coefficient, which measures the linearity of two variables. We can also take a look at a linear regression, which is going to test the significance between an independent and a dependent variable. The difference between a correlation coefficient and a linear regression is that a correlation coefficient shows if there's a relationship between the two variables, and a linear regression shows if that relationship is statistically significant. So in RStudio, we can use the summary function looking at the RPE of the team, and it's going to return the minimum, first quartile, the median, mean, third quartile, the max, and it's also going to return any NA values, or the count of NA values. We can use range to see the range, so it's going to give us the minimum and the maximum. IQR is the interquartile range, so that's the third quartile minus the first quartile. We can run the mean or the standard deviation and the variance to show the spread of the data there. Now, if we want to calculate the z-score, we're going to have to use the mutate function. We're going to call our new column z underscore score, and then we're going to use the max speed. We're going to use the current value of the max speed. We're subtracting the average max speed, and then we're dividing by the standard deviation of the max speed. When we run that line of code there, it's going to return it as the last column. So we're going to scroll all the way over here, and we see we have the z-scores of the max speed. In the next video, we're going to look at how we can utilize visualizations to help us understand z-scores a little bit better. To calculate the correlation coefficient of two variables, we're going to call on our data frame. We're going to use the summarize function, and we're going to call it RPE underscore distance because we're comparing RPE and distance. And we're using the core, which is correlation coefficient, of RPE and distance. And because there's NA values in our data frame, we're going to use the phrase use equals complete OBS. When we run that there, it's calculating the correlation coefficient between RPE and distance, and we see that there's a very strong correlation coefficient between RPE and distance. Now, if we wanted to take our correlation coefficient to the next level, we can use the group by function. We're going to group by the athlete's name, and we're going to use that same line of code here. And now what it's going to return is it's going to return an individualized correlation coefficient for each athlete. So now we can be a little bit more specific with our correlation coefficients. We can do it one more step where we can actually look at the session type, so either practice or game, as well as the athlete's name, and then we're going to arrange it by the athlete's name so we can see how correlation coefficients change between athletes from practice and game. So we can scroll up here, we can see the correlation coefficient for Aaron on game days is actually a little bit lower than it is for his practice correlation coefficient. We can also take a look and see if there's any outliers. So we see here Trevor has a really big difference in his correlation coefficient. So we need to ask Trevor, make sure that he's inputting his RPE correctly in whatever way that we're gathering the data from him. The last descriptive statistics test that we can run is a linear model. So we can look at the relationship between RPE and distance. We already saw that there's a strong correlation coefficient. Now we can test whether or not that correlation is significant. So we're going to call the model RPE underscore distance. We're going to call on LM function, the linear model. We're looking at RPE and distance using a tilde in between the two. And then we are calling on our data frame is workout underscore routine underscore dirty. And then once we run that line of code there, we're going to take a look at the summary of that model. So when we run these two lines of code here, it's going to return our summary here. So the two values that we're interested in when we're looking at our linear model are going to be our p-value. So we have a p-value of less than 2 to the negative 16. So an extremely small p-value means it's statistically significant. And then our adjusted r-squared of 0.67. And that's going to show how much RPE changes based off of the changes in distance. In our next video, we're going to take a look at how we can visualize these statistics to make it a little bit easier to understand. If you like this video, please give it a thumbs up. Thanks.